What's going on, everybody? Today is December 5th, and you're listening and watching Daily AI Show Live. And as you can see on the screen today, we're talking about Chatbots Reimagined. Specifically, we're talking about RAG methods. So that is the kind of, oh, there goes the music. That's kind of the goal for today. As it stands right now, as we get going, we've got Junie, Beth, Andy, and I'm Brian. We'll see if Robert or Carl are able to pop in here. But sort of the goal, like I said, today is just to sort of talk about these RAG methods, what it stands for, what it is, what it isn't, why maybe, I don't know. And this is for you guys because this is definitely my area of experience. But what I would love to know is how does it differ from using a knowledge base for maybe a custom GPT? What does it mean when you have enterprise solutions like what NVIDIA put out with their Nemo retriever? And what is that? Why does that help businesses? So that's kind of where my brain is. I'd love to learn from you guys. I don't know, Andy, I heard you talking before. Do you want to kind of kick things off, or does somebody else want to jump on this?
Right. So what we're talking about are large language models, which are transformers. So transformers take the words that you put into them and they create what are called embeddings. And that's a mathematical representation of each, almost down to several letters at a time. It chunks the words that you put in. It chunks them and also timestamp each one as they're fed in. Those embeddings are then fed through the multiple, the zillions of layers of, artificial neurons in that network, and the output is based on what the pre-training of that transformer model was. So that's basically taking advantage of the incredible scale of training of a large language model. But what if you want to add specific knowledge about your company or about something that isn't in the pre-training? It's just it's not in the books that were used or the websites that were used for the pre-training. Well, that's where retrieval augmented generation, or RAG, comes in. And what that does is it adds additional context at the time you send in your prompt as embeddings. And your prompt, by the way, when you put it in, it becomes an embedding as well. So with a stream that's going into the model are all these mathematical representations of the words. But the retrieval augmented generation method has a separate database. That's the knowledge database. And in fact, to your point, Brian, there is no difference between RAG and knowledge in a GPT. That is a RAG method. It goes out and it grabs a bunch of relevant information from the database. They're already in the database in the form of embeddings, because if you put information into a vector database for vector search at runtime, to pull it in as additional context, to add to the knowledge and prior training of the foundation model, then you only want to bring in a certain amount of that information that's particularly relevant to the query. So the embeddings that are created when you write your prompt are then thrown into the vector database that is also made up of all these embeddings of the knowledge that you've added there. And the similarity by mathematical semantic reasoning brings back only a small number that are particularly relevant to the prompt. That's important because all these large language models have a context window, meaning the number of tokens that you can put in, that they allow you to put in. But those context windows are getting bigger and bigger. So you can, there's practically no limit now to the amount of special knowledge that you can put into a vector database or into the knowledge database in GPTs that you can then add as context. And that whole methodology of using embeddings in a large language model and bringing information from outside the model's training in at the time that you're sending in your prompt, that's retrieval augmented generation.
Okay, so that was excellent. Thank you. So my first follow-up question to anybody on this is, it sounds like you said that the database, if you will, whatever the RAG is going to, the database, that is in fact vectorized. Is that correct?
That's right.
Okay. So, and this is something I don't know.
Purposes. One is it's easy to calculate semantic similarity using vectors, right? And it's faster, right? So you're looking for speed in retrieval and also accuracy, and that's why a vector database is used.
And so my second follow-up question is, now when you look at like maybe enterprise level, NVIDIA seems to be saying with their Nemo retriever, which is a product name, it's a RAG product name, that it's going to be accessing the databases. Are they saying that these databases they have sort of a suite of databases that you as the consumer, the business, can go in and say, well, look, this database is going to be the most relevant to me. It's geographical data. It's whatever. It's information about the Southeast specifically, and that means something to my company. So I want to take all my queries, all my questions as the user, and I'm going to ask for answers back. But I always wanted to go and reference against the known verified data in the Southeast, let's say. Is that what NVIDIA is doing? Or is NVIDIA saying, or any company, by the way, this is just the one I looked at earlier, any company that offers this, or are they saying, no, we're saying we'll help you get better access to your own cloud database? Or is it both?
Yeah, I don't know what NVIDIA is doing. I haven't read about that, but what I think they're saying is they will take all of your corporate data, they'll feed it into a vector database, and then you'll be able to pull them out. And you can have separate vector databases, right? So you can have metadata, which says, okay, if I classify this query as having to do with geographic locations, and it's a question about that, I'm going to tag that as being a geo search, and then I'm going to go to the geo database, right? Which that's a simple example, but that would be the way that you would use multiple databases that are separate and specialized. And that's maybe an artifact of the way data is held in relational databases today in enterprise.
Yeah, I think to just highlight what problem that NVIDIA is addressing with this new service is one of the drawbacks or the slower parts of RAG is retrieving that information. So NVIDIA service is all about speeding up the information retrieval process. And that's one of the steps you can do to just improve the output and experience of using a RAG system. So I think that's their main application there. And of course, this is the path that they've been going on for a while, is providing, the shovels and pickaxes to the larger AI development environment.
Yeah. Carl, give us a graph.
Yeah. So I wanted to share, just to give our audience a visualization of what this actually looks like. So, second. Okay.
Sorry, let me know when you want me to add it.
Got it. Yeah.
Okay.
So what Andy is talking about is the vector store, right? So, and the vector store could be anything. Could be Chroma, could be Pinecone. I think Amazon has Kendra. That's why I'm always curious, what is the vector store for various companies? What do they use? Because if you look at the steps here, a person asks a question, then the chatbot would also have what is the chat history. Then it would also look at what is the, what's the large language model that you're using. And then essentially there's two paths here. One is the question itself, which then it would search against the vector store. So let's stop there. Essentially, let's say you have documents, PDF documents. It would be chunked. So it can't feed the entire document. It's not like a regular database where you just put docs in. It has to actually split all the unstructured data and structured data. It splits them apart. It's to these chunks. How they split it apart depends, but most of the time it's just randomly split it apart. And then it turns it into embeddings. which are numbers, numerical representations of words. So for example, the word dog would be numerically closer to the word pet than the word alligator or crocodile, which would be actually still numerically closer to the word pet than, I don't know, a dragon. Just go down that line. So, and so when a question is asked, it reviews what is in the question, what words are in the question, and then tries to compare it against the database, against all the embeddings. And then from there, connects back and then gets your questions answered, right? And then goes through, the large language model again, and then outputs your answer. It's a very, brief overview of how this works every single time you put in a question. So when
a hybrid model, would you call that a hybrid model when you're using a RAG? Because it's not just going down one path. It's in fact, the language model is saying, well, the truest answer, the most correct answer for the end user could be a combination of pieces and parts of what's
Correct.
stored in vector in the database for the company, as well as, GPT-4 being GPT-4 and having a trillions and trillions of parameters, language model as well.
There's two things on that. The first one is, yes, depending on what is the, I guess you can call it base prompt, you can call it instructions for the actual chatbot. So if the instructions is, you will not answer any questions outside the vector store, if the chatbot is actually like created well, then it won't use its pre-trained data. It will just only use vector store data.
And that would be a temperature of like 0, basically.
0
Yeah.
with the
No
instruction,
creativity.
nothing, no creativity, don't answer anything outside of that. But then you could also open the chatbot up and allow it to pull from its pre-trained data at the same time. But that actually connects to number 2. And it was a very interesting post by Ethan Mollick yesterday about, he was saying that the RAG model is not the best use case for using company data because it hallucinates. That was his point. I would disagree to a point if the only thing you use AI is to use it for RAG. To me, that doesn't make any sense. That yes, it will hallucinate depending on how you base prompt it, depending on what information you provide it, all these things, all these different factors. But there's so many other potential AI uses beyond RAG, and RAG is always improving. What's interesting, Andy, and Brian, when you're talking about what NVIDIA was talking about, is are they if you pull up the graph again,
sure.
If each vector store, you can put a namespace. So the namespace would be like 2021, 2020, whatever. And essentially it buckets the information. So if I asked a question against 2021, then it would pull from 2021. And you can name it anything you want. But it's interesting. Are you talking about multiple vector stores then that it would be pulling from? Is that, I don't know. That's more of a hypothetical question for NVIDIA. Are they talking about multiple things that they can start pulling from in addition to its pre-trained data, which would be fascinating? Or are they just talking about a bunch of namespaces inside the vector store? So here's one would be China, one would be United States, one would be, I don't know, Brazil, one would be Japan, whatever that is. Or, which would make it crazy, multiple vector stores connected to the same. But I have a feeling that would require probably some sort of compute power, which then I would imagine you'd probably need GPUs for it, which then I would imagine, great job, NVIDIA.
Mm-hmm.
So is this, okay, let's compare and contrast against fine tuning. RAG, compare and contrast to fine tuning. When would a business, let's just say mid-market, let's not maybe go enterprise, but when would a business maybe lean towards a RAG method or methodology or use case versus attempting to fine tune? Is RAG the easier and the first place to start, most likely, as well as like good prompting?
Yes, absolutely. Yeah. It's significantly more difficult technically to do fine tuning. It requires some AI engineers in your staff to do that. Now, there's probably some tools out there that will help you do that in a rudimentary way, but you know, the RAG systems that are out there, like the chatbots that are in use broadly by people in the AI exchange, for example, Chatbase, Retune, Dante, etc., Vellum, those are all RAG systems. Nobody's trying to tune the models. Now, there are efficient ways to fine tune a model, which is basically instead of trying to retrain by adding weights to the original foundation model, which, by the way, you don't have access to when you're working with OpenAI or Claude or anything else. They're not letting you touch the weights in their models. But there are methods where you can take an open source model. This gets to the point about the complexity. Now you've got to mount your own, you know, open source model, and then you're going to use a ranking system called LoRa, probably, in order to create a new layer on top of that model that you provide training to, which reduces the overall compute cost necessary to do full retraining of a foundation model. You can retrain a model, but that can be, if you put even like 5 billion parameters into it, that can cost you 100 grand. So you're not wanting to do that. Whereas you use the RAG method and it's free. Well, except for the cost of the people who are, you know, doing
it. Right. Yeah, no, that's a real good point. I think that's the number one point, that when people are comparing the two, it's definitely the price for implementation of RAG versus fine tuning. I think the other consideration is how specific you're trying to get that model. Right? The more specific the task, if you want to build specific models for specific tasks or specific information or whatnot, that then you get closer to the reasons to spend the money on the fine tuning versus just let's see what we can do now and staying with the RAG method.
So think about it as RAG will let you bring in additional knowledge like facts, figures, examples, etc., into a small context window, but it does it efficiently by using this semantic vector search. Brings in only the relevant stuff, relevant to the query, that is. And by contrast, if you wanted to do fine tuning, you're probably motivated because you need to advance its reasoning capabilities, the model's reasoning capabilities around a certain kind of process. So you know, there's logic that we know and there's rules, and what the fine tuning process would do would be give a whole bunch of marked up examples to the training process, running these through GPUs at high expense to change the weights in a model so that it has some experience with the kind of logic in the tasks that you have that are specific in your enterprise. So that's just expensive. It's a big load. It's a heavy burden to do that. So probably most people listening to this are not going to be thinking about fine tuning.
So,
like something.
Oh, sorry, Beth. Go ahead.
So I'm just wondering how web search comes into this, because web search is obviously going out and retrieving information. Is there a just-in-time RAG, right? Does it like quickly like convert it to numbers and assess it in that moment and then add it to the knowledge?
And both ChatGPT with web browsing and Perplexity basically do retrieval augmented generation, where the web search is the retrieval. So it's going out, instead of going to a vector database, they have a really fast computing with, you know, crawlers that are really, really speedy. Perplexity does, and so does ChatGPT. And they bring back this new set of embeddings to load into the context window, but they can't go beyond the context window, right? So they're compressing it down to the things that they think are most relevant, and that's the value of really good crawler search technology. It's going to bring back the things that are relevant.
Yeah.
So when you see that little analyzing, it's basically singing a little embedding and converting song to itself.
Well,
and
remember,
then it's
even your
coming out.
prompts are being changed into embeddings,
Right.
right?
Right. That's true.
It's all the same pipeline. And when your final delivery of knowledge and prompt go in, it's just a stream of embeddings.
And I think like when a tool like a custom AI chatbot, I think this is where the difference between a GPT at the moment and a custom AI chatbot is. Custom AI chatbots can train on web pages where it actually goes to the web page. Before even a question is asked, you can train on multiple pages and they would turn those into embeddings. I think that there's two different functions. One is turn those into embeddings, and the other one is actually do it in real time. So previously, custom AI chatbots can't do that in real time, while GPTs can. They can actually do the search while you're, doing the search. So it's a fascinating thing. But actually, just going back to fine tuning and RAG, the one thing I did find is you could do a poor person version of fine tuning depending on the use case. And here's an example. I wanted to create normally you would fine tune this use case because it's like, hey, I want the output of the model to ensure whenever we ask it a question about, creating paid media ads, it would create paid, like the type of responses that we would normally have fine-tuned it on, like 100 question and answers. And these are the type of answers. This is what we want to find. But what you could do is actually in your RAG, it has to do the instruction. You can instruct it to using the information in the, in the knowledge base. I want you to output it exactly like, use the voice, tone, blah, whatever it is, writing style, XXX, more of that, like whatever's inside it. And what we found is once we did that, the output is actually really, really good. So we're not retrieving data. We're using it as the the instruction is, if you're asked anything other than paid media ads, do not answer. So we've instructed it not to retrieve data, I guess to kind of read data and ensure that the output of what we're trying to do matches what's in the database. So you could say that is a poor version of fine tuning. And, we A/B tested it. It did really well. So there are ways to, I think, use RAG beyond just data retrieval, which I think GPTs opens the door significantly than traditional. It's funny when I say traditional, but it's not. It's only been less than a year.
Yeah, it's long.
Custom AI chatbots versus GPTs.
Yeah. So it sounds like it's reducing. What you're talking about is not necessarily, you don't necessarily need it to pull back directly from this database. You're using the database to reduce hallucinations.
But the task I'm doing is write paid media copy. I don't need it to retrieve specific information that has to be accurate. I need it to be creative based on, right? So it's a different use. So there is no, I don't need it to pull any type of data. So it can hallucinate all at once. I want it to be creative, but it's different. Yeah. So
because accuracy is not your main goal.
Accuracy not. And one last point here too is from when you compare a GPT to a traditional RAG model, you cannot ask the RAG against its own knowledge source. So if you actually type in execute like this page, or like ask it about, because remember it chunks it all. Right. So you can't ask you can ask, hey, on page 36, what is the word? It'll bring it all back. But if you ask specifically about knowledge sources or take that one step further, execute against the knowledge source. So like execute document 3. You can't do that with a traditional RAG. You can with the GPT, which opens so many other doors, whether execute code, execute prompts. Like that is really cool to be able to pick and choose, because there was a use case that I saw yesterday. It was like, oh, I want to create prompts for different languages and enable the person to do that. It's like, oh, in your GPT, just add however each document you upload, add a prompt for different, for each country. Then the user can be like, execute China prompt.
Right.
That would go.
I think
you can't do that with the traditional RAG.
That's an important point, Carla. You're making a distinction between what the packaged RAG systems like Chatbase and Retune do, which is they provide an easy interface to upload documents, but when they put those documents in, they don't put them in as named documents that can be specifically referenced. It puts all that knowledge into the embeddings and then into the data store. Yep. It's a limitation of their implementation, which GPT surmounted by letting you put up named documents, and you can reference those in your prompt.
Right.
And and when this first came, it became clear that you could, and as many of the more sophisticated GPTs do today, you can put a lot of the instructions into the documents in knowledge. And just in your simple prompt, you can say, okay, step 1, look at this document and do this. Step 2, look at this document and follow the instructions in there. When you're finished, come back and do the next step.
Yep. And I think that's, as we're sort of getting to the end here, I think one of the things I wanted to at least bring up is just the importance of having clean data. It's something I know I've brought up, many times, but, whether it's a, paid database or whether it's a database that your company creates itself or already had, despite vectoring and chunking on all of that, it's not necessarily going to do a fantastic job if your data is unstructured. And I can tell you a simple version of this that I ran into, where the PDFs that this chatbot was referencing did not have simple top-down like headings, right? So heading 1 was whatever. On the PDF, as a human, it was left and right in 2 different text boxes. So if you can imagine, you have headers on your left and you have sub bullets on your right. Well, I haven't, at least up until this point, found a system that will read that correctly. Now, one workaround was to actually convert those PDFs into HTML, and that started, when you look at the HTML in like a Google tab, that started to align things correctly. But never mind that use case. This just happens to be one of my use cases. You could say this for anything, I think, is just that you do have to look. It's not just as easy as take whatever you have and throw it in there, and the magic vector pinecone is going to handle all of it miraculously, chunk it correctly, and put everything where it needs to do, and make its mathematical triangulations as to where in a 3D model these words are most closely related, like dog and pet, or whatever the case may be, or alligator and pet, right? So I think it's just worth mentioning as sort of maybe towards the end here, and get your guys' opinion on it. But you do have to be careful. It's not a magic wand. You do have to really work. And I think companies, and there's obviously lots of companies who sell data. I can think of companies I've worked with that sell very, very meticulous high-end data on the ultra high wealthy, the whole ultra high net worth people of the world, right? You're less than your 1%. It's probably 1% of 1% people, because they're trying to seek out them for charitable causes and things like this. That data set is highly, highly curated and detailed. And it's like, that's what that company does, is make sure that data set is as good as it possibly can. There's a giant difference between connecting to a data set like that if you are a nonprofit, as opposed to maybe connecting to something you could, pull off the internet or whatever the case may be. So anyway, just worth mentioning, I think, that there's value in people who curate and manage and consistently prune and clean really, really good data sets. And that, I think, is going to continue to be a massive market as you have these, what appears to be these RAG methods of, hey, I need that data to be absolutely perfect so that when I use this method, I know that my answers are not hallucinating or not giving back erroneous information. I don't know. Is that how you guys see it as well? And just sort of where my brain is with this right now.
I think there are some weaknesses of the custom AI chatbots is when you say it does better in unstructured data than it does with structured data. So, and when you talk about PDFs, it very depends. Is it natural? Like, is it a picture PDF where you need to OCR it, or is it like a PDF create? So that's one in itself. And then remember with custom chatbots, remember how it chunks everything. So if you take like a spreadsheet and chunk that, and you want it to answer in a specific way, you actually have to find a way to either ask the question or put some sort of process in place so it retrieves the data in order, not as. So it's easy to say, oh, in cell number 4, like it'll find the specific, but if you want to analyze it on the whole, it'll hallucinate like crazy. It doesn't matter what the instructions are. So people have been working around that's like, oh, you take a picture of a PDF, I mean a spreadsheet, and then and then turn it into a web page. That would be a way to bypass that, and then it would actually do a much better job. But what which I haven't tested yet with the GPT is I'd be very curious to see how they read CSVs versus
well, they have code interpreter, which has been specifically trained to do that.
Then you don't, it does it so much better than that's another advantage for a GPT versus a custom chatbot, especially on structured data, which is hard to read using the embeddings in vector store at the moment.
And this is one of those places where we're using different capabilities of GPTs together, right? So that we talk about the magic of retrieval augmented generation. That's actually, the generation is its own magic, and its own magic is like confidence, right? So it is going to give you erroneous information as confidently as it is going to give you accurate information. And the retrieval itself is a kind of magic. It's more similar to what we do when we search something. And the augmentation is then like, what emphasis, where are you, in what way is it augmented? And those capabilities are shifting as are shifting faster in the scenario, I think, than the other two pieces, right? So what we're talking about today and the way that like this is magic in this way may be super different in 2 weeks because of the ways that something can be augmented.
Or even just how like things could be embedded, like like something like LangChain has for the past year improved their systems. So in a month, the way that this whole thing is being done could be completely changed, which is really fascinating on how data is retrieved and so on.
Hey, and make sure that we have content for the next several years with AI. That's why we picked AI, because we knew for sure we would never run out of something to talk about on any given day. I guess we'll wrap it up there unless there's any last thoughts. Hopefully, for our audience, you guys, learn something from this. You understand more about RAG. I know I learned a lot here because I definitely was coming into this going like, okay, I think I get it, but I'm not 100% sure. So this is super helpful. Don't forget the rest of this week. Tomorrow we'll be talking about all the AI in the news that came up over the last 7 days. So we'll be talking about that. On Thursday, we're talking about transforming images into motion. using AI. So there's been a lot of that in the last week. Some of that will probably come up in the news tomorrow. But we're going to look at some of these different tools that, like Runway ML and Decoherent, some other ones in there that we've been sort of messing around with, which are actually really, really cool. And then Friday, we got Lego My Ego. No, we got Meta's Ego, Ego, Exo, 4D. It's all of that. It's a great name, but Andy did explain it to us, so we'll bring that back up on Friday, talking about their augmented reality and what they're doing with their language and learning models, and not learning models, but their learning pathways and things like that. Should be super interesting on Friday. So that's it. Any last thoughts before we go?
Real quick, I don't think data handling and data processing is really going to change. Your basic approach to making sure your data is clean as part of your process, that's a standard. That's not going to change.
Right.
My TLDR is, if you want to just get access to the incredible knowledge that's already in the pre-trained GPT-4 world in OpenAI or Claude 2, you just prompt. You just type in your query, you type in your questions. But if you want to do something that has reference to your personal documents and knowledge, then you use RAG. And the fastest and easiest way to get to that is to have a Plus subscription on OpenAI and create your own GPT. You upload those documents and they're a part of that process.
Yeah.
All right. We'll leave it there. All right, guys. Have a great rest of your Tuesday if you're listening to us live, and we will be back the rest of this week. Can't wait to see everybody tomorrow. Bye.
Aloha.